All right, today we're just going to build off what we already know. So you're going to see why in a second, why it's important to have a real quick way to graph these. And I know I could see that I could see that some of you were still plotting a lot of points. You need to get to kind of where, like when you think parabola, you're thinking, oh yeah, 1, 1, 2, 4. And boom, you can just plot them, and 0, 0. You can just plot them on it. Or square root, you can go 0, 0, 1, 1, 4, 2. And think about those major points in the sketch. And you'll see, because as you'll see with this shifts, reflections, stretches worksheet, you're going to maybe look at there and see the basic function in there, but it's going to have a lot of junk going on. Okay, so here's the idea on shifts, reflections, stretches, reflections. I'm sorry, I've already said reflections. Shifts, reflections, and stretches. So anytime, well, like right here, you can see that that is a parabola, right? You can see the x squared. But a couple things happened to that parabola. It looked like inside the squared part, I subtracted 3. Now you already know what that means. You know that the vertex x coordinate is 3, right? And to get to 3, you would have to move 3 to the right. Well, that means there was a shift of 3 to the right of the regular graph. So anytime you see a number being added or subtracted on the inside, you're going to move basically the y-axis 3, or the opposite of that sign. So if it's like a -3, you're going to move it right 3. And I'm going to draw that and basically put a dotted line here. Okay, now for those of you who are thinking, I already know how to do parabolas, why are you making it harder? Again, we're going to do this with all the graphs, so I think it'll help in the long run. All right, then, anytime you see a number being added or subtracted outside of whatever the function is, whether it's an x squared or an x cubed or an absolute value, on the outside, that you know from before, that would have been over here, the original way we did parabolas, right? And that would have meant the y-coordinate was a +2, which meant up 2. Well, now it's not going to be looking like that. It's going to be over here on the right. So whatever happens on the outside of the function right here, you move it in that direction. So if it's +2, you move it up 2. If it's -3, you move it down 3. So I'm going to move the x-axis essentially up 2. And look, there's my new vertex. Now, again, you already knew how to find a vertex 3, 2. But what this does is now I have already dealt with the -3, and I've already dealt with the 2 at the end, and all I have left to graph is what? The 2x squared. So literally, I can graph now this y equals 2x squared on my new x and y axis. Now the 2, and it makes sense when you look at it now, the 2 is just doubling whatever would have happened after you plug the number in, right? Now from your basic graph you just sketched today, what were the 5 points that you marked? And remember, we're on our new x and y axis, right? So you said 0, 0, 1, 1, 2, 4, and then -1, 1, -2, 4, right? Well, what do you think that 2 does to each y value? It didn't double the x value. If I plug 1 in, I just don't get 1 anymore. Now I get 2. So instead of going up 1, I go up double that. Instead of going up 4, I go up double that, which is way off the graph. And on the left, when I plug a -1 in, instead of going up 1, I'm going up double that. Instead of going up 4, I'm going up double that. So I just end up with a much steeper parabola. So the 2 is what it's being stretched. Jump over to number, I tell you what, we'll look at number 2, well, not number 2, but whatever that second one is. Second one, what kind of shift just happened? To the left, 1. So I'm going to go to the left, 1, because it's a +1. And then right there, a +3 tells me up 3. So I'm going to go to +3. And now that I have marked those shifts, I don't need to look at that +1 or that +3 anymore. So really, all I have left is a -x squared. And you already know what -x squared does. What does that mean? It means it's going down. We call that a reflection. When I'm negating the whole function. Now that's different, guys, than this. Do y'all see the difference between a negative x squared and a negative x squared. Okay, when you see a negative on the outside of the function, that flips the graph over the x-axis. When you see a negative on the inside of the function, that flips it like over the y-axis, which wouldn't do anything in this case at all, would it? And you can see that it wouldn't do anything because when you square it, you get a positive x squared. So sometimes a reflection of the y-axis does nothing. Sometimes a reflection of the x-axis won't do anything. Well, that will do something because we're dealing with functions, but you'll see that sometimes the negative just doesn't do what you might think it does, but that's what it means. So a negative on the outside, we're going to take whatever I would have graphed, reflect it down. Now, I don't have to overthink about it. Again, I can just think about it like a stretch. I can think like right here, whatever I was going to do, I doubled it. Well, whatever you were going to do, multiply it by -1. So what points was I going to mark here? 0, up 0. Well, I'm going to go up 0 times -1, which is still 0. 1, up 1, right? But instead of going up 1, I'm going to go 1 times -1, which is down 1. Over 2, up 4. But instead of going up 4, I'm going to go 4 times -1, down 4. And I'm going to do that basically for all of it. Now, if you want to think reflection, great. Reflection's awesome. Instead of doing right there, you're just going to reverse it and go this way. Now, since I have plenty of room to still graph, what other points do you think I could mark? 3, 9, or actually over, instead of 2, 4, I could go 3 down to 9. So if you could squeeze an extra one in there, great, squeeze an extra one in there. And then finally, look over here. Tell me real quickly, what are the shifts? So left 1, I'm going to mark that with a vertical -1. Down 3, I'm going to mark that with a horizontal -3. And I'm literally shifting the whole axis left and down. Now I'm done. I'm finished looking at the 1 and the -3. So now I can just focus on what's left, which is the 1/2 x squared. Right? So from here, instead of marking, and I'm going to do it in red, instead of marking 0, 0, 1, 1, -1, 1, 2, 4, -2, 4, or even 3, 9 that actually fit on there, instead of marking those points, what would that 1/2 do to that? I would, instead of going up 1, I'm going to go up 1/2 of 1. That's not going to affect the 0. Instead of going up 4, I'm going to go up 1/2 of 4, which is 2. And instead of going up 9, I'm going to go up 1/2 of 9, which is 4.5. And I'm going to sketch that parabola. Now, again, you guys already had a pretty decent way to do parabolas. You know, you already studied those, but that was one particular function. There's all kinds of different functions, and we can apply this thinking to all of them. Y'all seeing this? Okay, I'm going to erase this. Y'all good with me erasing it? Okay. And let's scroll down to something a little different. I'm just going to be doing random ones because I really don't think we need to do all of these. Look at this number 2, the second one. Now you see what kind of function? So you know x cubes typically look like this, right? Kind of the John Travolta look. So if I have this, this x cubed graph, I first need to figure out how it's been shifted and whatever. So where are my shifts?
Over right 1.
Right 1, so I'm going to mark that. I know a lot of people don't like putting these dotted lines in there. Just do it. You know, I actually give points. If you don't even know what the graph looks like, but you mark your shifts, I actually give you 1/4 of the points. Like literally, if all you had on this was this, you're going to get something for knowing how to shift it because that's what we're learning. So people that get in the habit of not even putting shifts and they're trying to do too much in their head, that's so foolish. Because if you graph the wrong thing and I don't see the shifts, you get no credit. So if I see the shifts, great. But now I don't have to look at that -1 and that 3 because that's all they were doing to the x cubed graph. So all I have left is the y equals -2x cubed graph to deal with. Now, what would the normal points you plug on an x cubed graph?
1, 1.
down 2. So this was a stretch and a reflection, wasn't it? But you really don't really have to think about it. If you really think, hey, whatever I would have gone up, multiply it by -2. So now I'm down 2. And what I would have gone down, which was -1, I'm going to multiply it by -2, and I go up 2. So you can see it kind of got stretched and it got reflected. Now, there's no way that this next point's even going to show up. I mean, think about it. If I plug a 2 in there, I get -16. That's way off the page. So I'm just going to come down here and just really be diving down.
Shouldn't it be a 2-2 instead of 2-1? Or is that right?
No, like what I would have plotted on a normal x cubed graph based on this new dotted line would have been that point, right? Which is up 1, but not a 3, that's supposed to be a bracket. That little distance right there would be up 1. But if I multiply up 1 by a -2, now I'm -2.
So not from the point, but from the line, the new line? Like not from the point.
I'm measuring these from my new x-axis. Because this is, like, if this is my x-axis, I'm going y equals 1, y equals 2, y equals 3. I'm ignoring the old x and y. They are not part of the picture because my shifts have changed my axes. Are y'all seeing that? So if I can apply the shift mentality, then it's like this is my new x-axis. Some people would call that x prime, y prime. It's my new kind of pretend x-axis. But what that allows me to do is simplify the look of my graph and graph that simple looking graph on my new x and y. Heck, think about it, just plug points in there. If I plug a 0 in there, I get y equals 0. If I plug a 1 in there, I get y equals -2. If I plug a -1 in there, I get y equals +2. I can still plug points, but I'm doing it based on my new x and y axis because I've shifted to account for that. And I can still plot points on the original one. I mean, I could literally ignore everything you've done today and do that, but I'm getting all these crazy points in here, and I'm not going to have a great vision of what they are, especially when I start having asymptotic graphs, things like that. You're going to have like point here, point there, and you're going to go, what's going on? But if I can sketch the asymptotes, sketch my shifts, I'm telling you, it's going to seem a lot more simple to get there. All right, let's jump to like number 3 or whatever. Look at number 3's graphs. So what is this telling you to do? Shift right 2. So I'm going to shift to the right 2. And what about, and then so nothing up and down, so same axis. And just keep that one. So this is my new x and y axis, and I do not have to worry about the -2 anymore. So I'm essentially just graphing 1/4 of the absolute value of x. Now, what would a normal absolute value of x look like? Right? It'd be a v with the slopes of 1 and -1. So now what do I have? Slopes of 1/4 and a -1/4 because I'm going up not 1, but 1/4 of 1. So instead of going up 1, I'm doing 1/4 of 1. Instead of right here going up 2, I'm going up 1/4 of 2. Instead of right here going up 3, I'm going 1/4 of 3. Instead of here going up 4, I'm going 1/4 of 4. But I'm doing 1/4 of whatever I would do. But I think it's easier to look at this and think about this as a slope. Rise 1, run 4. Rise 1, run -4. And that gives me that looking graph. And let's look at the next one. What are the shifts on this next one? Left 3, down 1. So left 3, down 1. And I am finished looking at the +3 and the -1. So all I have to do is graph -2 absolute value of x. Now I'm going to put a dotted line in where the original absolute value of x would have looked like. This is what a normal absolute value of x would have looked like, right? This is why it's good to know this. So if the normal one would have looked like that, what happens when I multiply every one of those y values by -2? What does the negative do? Flips it down, and the 2 doubles the amount. So on this first one, instead of going 1, 1, I'm going 1, -2. Instead of going 2, 2, I'm going 2, -4. And I could do that on both sides, and that's about all I can fit in here. Or like I said before, you could think about it as a slope of -2 and a slope of +2. Down 2 over 1, down 2 over 1. So you don't want these little dotted lines in there that I put in there initially. Y'all seen it? All right, let me keep throwing you some curveballs. What about this next one? Now, we already know what function is this? It's absolute value. We already know that's that little hook to the right, right? So, I'm sorry, square root. We already know square root's a little hook to the right, right? Normally. But if the negative was on the outside, like this is a square root function right here. This is what we graphed on our quiz. And I said if you have a negative on the outside, what does that do? Reflects it over the x-axis, right? Well, what does a negative on the inside do? It reflects it over the y-axis. All right? Now, it makes sense if you think about it. What happens if I plug -4 in for x? If I plug -4 in there, the negative that's already there makes it positive, and I square it to 4 and I'm up 2. There I am. If I plug a -1 in there, the negative that's already there makes it positive. I square it to 1 and I'm up 1. If I plug a 0, I get a 0. What happens if I plug a 1? I get a -1 and it doesn't exist, right? So you can see that it reflects it, but it'd be a whole lot easier if you just knew that and you didn't have to actually start plugging points again. So when I see this, I go, well, now, by the way, this is not, don't look at that negative and go, oh, I got to go shift it to the right one. That's not x minus 1 under there. It's not that, is it? It's a negative out in front. So there's really nothing being subtracted from x, is there? So no shift this way. But what does the -4 do? Down 4. So here's my new x and y axis. So all I have to do is reflect the original square root function. And if the original one was this, a negative on the inside reflects it over the y-axis. So it must, I'm just going to take that point, put it over here, take this point, put it over here, and reflect it that way. Now let me help you remember this. This is lame and dorky, whatever, but it might help. Okay, there's two kinds of reflections. There's this one, where the negative is on the outside of the function, right? And then there's this one, where the negative is on the inside of the function. Now this may or may not help you, whatever. Okay, where do you see your reflections when you are outside? Outside walking around, can you see your reflections? Where?
In a puddle.
In a puddle, and puddles are on the ground, right? Right? So you see your reflection into that puddle. So right here, if you see a negative on the outside, the regular graph is going to be reflected into the puddle, and then you're going to see it on the other side. Where do you see reflections on the inside? On a mirror or on a wall, right? Unless there's a big puddle on the floor, but probably on a wall. So on a wall, you see a reflection over a vertical axis, right? So on a wall, you see that reflection into the mirror on the other side of the mirror, on the other side of the wall. So inside negatives reflect over that vertical like that, like a wall. Outside negatives reflect like over a puddle. Y'all seeing that? So that may or may not help you. I don't know. Let's see. Okay, so but you definitely don't want that part. So what would I do here? Left 3, down 1, and from this, now you don't have to worry about the 3 and the 1. It's out of play. You just have a simple 2 root x. So what's that 2 doing to every y value? Doubling it. So what you would have had was you would have plotted 0, 0, 1, 1, 4, 2 normally, right? So double that up 1 to up 2, and double that up 2 to up 4. And since you have room, I could have plugged in 9 and got 3, double that 3 to up 6. Again, you can always fit in another point. I mean, not always, but sometimes you can fit in another point. All right, what about these? Number 5. I tell you what, I'm going to be more selective since we're down to what? Oh, no, we got step 15. And I think we are going to be a full day behind. I was hoping to get a little bit more in today. It's not going to happen. So I think we're just going to, everything on your assignment sheet, I might even reprint it for Monday, but I don't have anything now. Just, we are a full day behind at this point. So no worries. So the homework for tonight will be Thursday nights. The homework for Monday will be Fridays. So So until you get a new sheet, make sure you're doing the right homework and getting it in, all right? All right, so right here, how about, let's do this one over here. Now, can you see the original function? We're doing this one right here. The 1 over x squared, and that was the 1 over x squared was the volcano, right? So we're looking for a volcano graph that might have been changed some. So what were the changes? Left 1. So, and we know that that left 1 in this case is not just a shift. It always also represents the what? The vertical asymptote. So it's the new y-axis and the vertical asymptote. And then what else? Up 3. And we also know that this represents a horizontal asymptote as well as the shift up 3. But look how much simpler I've made it already. I'm down to y equals -2 over x squared. Now, isn't -2 over x squared the same thing as -2 times 1 over x squared? So that -2 is just your what? It's your stretch and your reflection. But again, you don't have to overly think about it. You could say, well, what points do I normally put on a volcano graph? I normally just put 1, 1, and then I just say, okay, I know it's going up. That's really all I was looking for. Except on this one, instead of going up 1, I'm going to do what? Down a 2. So, because -2 times that 1 is -2. So I'm going to go down a 2 on both of those, and then I'm just going to sketch it from there. And I'm not overly picky about that kind of stuff. I mean, you actually should be hitting that point, these extra 2 points that I'm marking in there, but I'm not going to quibble about those. But the ones I'm pointing arrows at, those are the ones I'm really looking for. Because I need to see that you know that you're going down that 2 for those particular points. All right, what about 6? I saw a couple mistakes on y'all's with exponential. For the most part, y'all's quizzes were really good. Mostly 25s, 26s, 25 and a halves, lots of 26s. But like right here, what graph do you see? The 2 to the x? But a couple things happened right now. It's 2 to the x. Was anything subtracted from the x? No, so there's no shift there. Was anything added or subtracted on the outside of the function? -3, so down 3. So I'm done with that, and all I have to deal with is this. Now that negative is on the inside of the function, isn't it? Y'all see the difference between y equals -2 to the x as y, the difference between that and this. So this negative is on the outside of the function. Outside reflects over. This x is on the inside of the function. Inside reflects what? Over the y. So a normal exponential function, what points would you have marked? 0, 1, and 1, 2. And since I have room, 2, 4, actually, you could even do 3, 8. You could fit all those in there. Right? I mean, again, this is what it would look like without the negative. So without the negative, your graph would have looked something like this. So what does that negative do? Reflects it over the y-axis. So you can take that point and mark it here, that point and mark it here, leave that one alone, and send this graph down that way. Does that make sense? Now, you could also plot some points, couldn't you? What points are you going to like to plug in there? You can plug 1 in. What's 2 to the -1? 1/2? There we are. Over 1, up 1/2 on our new x and y axis. You can plug 2 in. What's 2 to the -2? 1/4 over 2, up 1/4. But wouldn't it be easier to plug in -1? What's 2 to the -1? 2 to the 1, 2. Plug in a -2. What's 2 to the -2? 2 squared, 4. So at -2, I'm up 4. Are y'all seeing this? What about this? Where are my shifts? Right 2, up 1, and I do not have to look at the -2 and the 1 anymore. Man, this is easy now. All I have is -3 to the x. What does a negative do? Is that on the outside or the inside? What do outside reflections do? Reflect it over the x-axis. So what would you have normally marked on a y equals 3 to the x? Heck, you don't even really have to do this. At this point, you can just plug in a 0 and get what? 3 to the 0 is 1, and then negate it. So at 0, negative 1, what happens if you plug a 1 in? 3 to the 0 is 3, then negate it, so at 1 we're down 3. And what did I say about exponentials? You just need 2 points, and then to understand that they always have what kind of asymptote? Horizontals. So if you have these 2 points, and you have that horizontal asymptote, do you really have much choice but to just follow the asymptote? That's what asymptotes do. They just get followed. Now, this last one's tricky. All right? So the rule is, on the negative, if I'm negating the x directly as opposed to the function, that negative is on the inside, and insides reflect over the y-axis, right? But the rule on the shift is, and this is the first time we've encountered this, the rule on the shift is I have to be, if I'm adding to x, I shift it left. If I'm subtracting from x, I shift it right, correct? But I'm not subtracting from x. I'm subtracting from what? Negative x. Well, that's messed up. So I need to rewrite this to be able to use my rules. So to rewrite it, whenever you have a negative on the inside, and this is the first time we've had to deal, I'm going to pull that negative out, and that leaves me x plus 1. And now I look at it and go, okay, I'm technically adding a 1 to an x now, which gives me what kind of shift? Left. You see how that's tricky? Because if I just look at the original problem and say, oh, I'm subtracting 1 from x, I'm not. I'm subtracting 1 from negative x. The rule is, what are you adding or subtracting from x? Now I can see that I'm adding a 1 to an x, shift to the left. I'm subtracting the 3, down 3. But now all I have left is 2e to the negative x to deal with, because the 1s and the negative 3 have been dealt with. Y'all see that? I'll probably do that to you once on a test. It's probably worth a point. It's not the end of the world. We'll talk more about it in pre-cal. So what do? What kind of a reflection is going on this one? If you negate on the inside directly to the x, I flip over the y. If you negate on the outside, that's on the function, then you flip over the x. So I'm flipping it over the y-axis. What would you have normally graphed here? Or just plug in some points. What are some easy points to plug in?
1.
I don't like 1 because I don't know what e to the negative 1 is. 0 is an easy point. 0 would give me 2 times e to the 0, which is 2. Great. 0 gives me a 2. I like negative 1. If I plug in a negative 1 here, what do I get? 2 times e to the 1, and what's e?
2.7.
What's 2.7 doubled? 5.4-ish? So if I'm plugging a negative 1, I'm up 1, 2, 3, 4, 5.4-ish. And what does every exponential function have? Horizontal asymptote. So if you have 2 points, can't you just connect those and go, all right, I got to follow the exponential? I follow the horizontal asymptote. Now, when I was plugging points in, did I actively think about a reflection? You really don't have to think about a reflection to graph these. The reason why I want you to know that it's a reflection is because when you go to an AP, when you go to a math tournament at the state, they're going to do this. If y equals f of x is this, then what is y equals negative f of x plus 3? And you know what they're going to want you to do? And they'll have a bunch of choices, but they want you to go, oh, well, that's shifted up 3. This is f. I'm going to shift up 3. And then I'm doing what with that negative on the outside of the function? You're flipping it down. So this function that would have been, this would have been the original function right here, right? That would have been the original function with the shift. Are y'all seeing that? Whole thing shifted up 3. So if I reflect it, what do? Flip it over. Are y'all seeing that? So you have to understand that it's a reflection to be able to do a problem like that. But to graph it, dude, I just think, what's the easiest number to plug in there? -1 and 0. If I plug in a -1, I get 2e. -1 up 5.4. If I plug a 0 in there, I get 2 times 1. 0 up 2. Horizontal, sketch. Makes it just a whole lot easier. Got 3 minutes. How about a log problem and then maybe one of these other ones? So number 7, how about the one in the middle right here? So number 1, tell me what I'm doing. Right 2 and up 3, and I no longer have to deal with those if I use my new and improved axis. So what would a log base 4 graph look like? What things do you have to know about a log graph? Vertical asymptote. Gotta have one. So that must be the vertical asymptote. And then what 2 easy points can you plug into that? Log 0 I can't do, unfortunately, because there's a VA there. But 1 I can. If I plug a 1 in, I get 0. So look at it from here, over 1, up 0. And then what's the other number? 4. But this time when I plug a 4 in, log base 4 of 4 is 1, but I'm negating it. So -1. So over 4, -1. Now I have 2 points. If I have 2 points and I know there's a VA, what does this thing have to do? Which way? Up, right? Can't flip around and go down. That doesn't really make a lot of sense. It doesn't look like a log graph anyway. And then let's do, I don't know what happened to number 8. Does yours look like that, or is yours better looking than this? You have the parentheses around it? Okay. Let's just do that middle one, that bird graph. All right, so you have is it 2/3?
It's not parentheses.
No, it's like the floor ceiling.
Yeah, it's like the floor ceiling.
The double parentheses.
Oh. Well, I don't have time for that in 2 minutes. Let's do this one. What does that look like?
Semicircle.
So it's a semicircle that has been what? Up 2. That takes care of that. And then it looks like it's just been what? Flipped over. But you already knew that, right? Because you remember from before when you were graphing these, it's a circle but with only negative y values. But you can see it now that it's just a reflection. So the radius is 4. So I'm going to mark 4 left, right, and then I'm going to go down 4 from my new x-axis because there was no change in the x-axis. And then I can just connect these as best I can. All right, guys. So your homework is this sheet, and just do the best you can. The key's up on Schoology, and if you have any questions, let me know. And if you're good, oh, and by the way, on the back of this sheet, okay, it's asking you to create the graph based on this stuff, but on the very back it talks about domain, range, zeros, x-intercepts, and symmetry. Don't worry about that. I think I made a note of that, but don't worry about 1 through 12. We're going to come back and do that the next step. Hey, y'all have a great weekend.
It's not like dropping to 0, so I'm going to go back to like. I should have at least.